This is Twit.
Microsoft is researching the possibility of using fuel cells to power their data centers. They're talking about doubling the efficiency of their data centers. Now, they're talking about right now their new data center in Cheyenne, Wyoming. The DC will be powered by methane. There's a big wastewater treatment plant right next to the location. They're going to be pumping methane out of the, what do you call that, the biodegrading waste products, putting it into a 300 kilowatt hour fuel cell and using it to power all the servers in their data center. It's clean because, as we know, a fuel cell doesn't actually burn it. It uses a catalyst to split the hydrogen out of any gas you give it, be it propane or methane. In this case, it's methane. And then it combines it with oxygen to make water, heat, and electricity. It's a fantastically efficient process, especially if you're pulling the gas out of a waste product like poop. That's right. I'm just going to call it now. It's poop. Now, here's something that's even cooler. They're talking about the next generation of their data centers already, and that means that they want to move away from having a huge 300 kilowatt hour fuel cell into thousands of 10 to 25 to 7 kilowatt hour fuel cells inside the racks themselves. Now, Cheebert, I want to throw this over to you first. We've heard about this idea before of moving the power generation as close to the servers as possible because that increases efficiency, right? How does it increase efficiency?
Well, you know, anytime you start transporting electricity over distance, even if you're using really efficient superconductors, you still lose some power along the way. So if you decrease the distance, you decrease the amount of power you lose. Of course, it has some problems, and Microsoft has definitely acknowledged that. Data centers are not exactly the safest place on the face of the earth, and putting in what is potentially an explosive gas into the racks could be a problem. But then again, no worse than pumping water in, because there's a lot of people talking about also using water-cooled servers in the data center. So it's just going to take time, and it's going to take some effort, and it's going to take some people working with safety experts.
Right. Yeah, there's definitely a lot of question marks that have to be sorted out before they use this technology on a large scale, where you actually have each rack with its own set of fuel cells. But there is a lot to be said about the efficiencies that you get when you're not making all those transitions. Let's take a common transmission line from a hydroelectric dam, which is pumping out a few kilowatt hours per generation unit. Now, that power has to be stepped up, turned into AC, transmitted over a bunch of lines, which then stepped back down, where it may then go into a transformer station, which will turn it into lower-powered AC, which will go to a data center, which then gets stepped down again before it goes to the racks, where it gets turned into DC and fed into the servers. What we're talking about here is a power generation technology that could potentially go straight from methane to DC into the servers. Curtis, there's not going to be an immediate ROI on this. I mean, it's more expensive to generate power this way. But long term, do you think the enterprise understands, beyond just the PR implications, but the benefits to having green power generation in these huge data farms?
Well, I think that when it comes to green power, there's a lot of questions, because let's admit it, aside from the PR value, there isn't a huge incentive in most locations to do green power. Now, it's entirely possible that Microsoft or some of these other companies could work out some sort of carbon offset-based rebates or special incentives with a state government. That's certainly possible. And frankly, I'm thrilled to see someone who is looking seriously at capturing and using methane, because it is a fairly potent climate change gas. This is exciting. It is early. I think that it's a good thing because it is one step in the right direction. A lot of people keep looking for the home run, the one technology that's going to replace big point generation power plants. I'm not sure we're going to get there. I think that having a bunch of different options is valuable. This is one of them. My only real question is this. You know, if some of the biodiesel that use recycled French fry oil have exhaust that smells like French fries, Do you really want to be in a place where you're using poop gas to generate your power? The exhaust could be an intrusion deterrent, I suppose, if nothing else.